चलो गाइस, तुम लोग अभी लॉग्ड इन रहो, तुम्हारा क्लास स्टार्ट होगा, एंड कुछ गड़बड़ होती है तो इमीडिएटली मुझे कॉल बैक कर लो, कुछ भी दिक्कत होती है तो।
होमवर्क कब तक सेंड करना है?
होमवर्क तुम्हें, हमारी क्लास कल है कि परसों है?
कल है।
कल है क्या?
हाँ सर।
हाँ
कल है। अच्छा सुनो ना, वो होमवर्क सिर्फ जो मैं तुम्हें बताता हूँ ना, वो होमवर्क एकदम 1 आवर का होमवर्क है, हार्डली अभी कुछ उसके अंदर काम है, तो मुझे कल तक सेंड करो ना, क्लास से पहले, दोपहर से पहले।
यस सर।
ठीक है,
आपको सेंड करना है ना?
मुझे 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 सेंड करना है, ठीक है? ओके,
बाय सर।
बाय 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 बाय।
Well, so we have finished the, what do you mean by, we have finished the vector mathematics part, and we want to discuss now the application part of vectors. Since you have only been exposed to kinematics, therefore I will only talk about the application of vectors to kinematics. Needless to say that this is how the concept of application of vectors is going to be used in the other topics of physics as well. Okay. So first, let me talk about, I think I talked about this last time as well. First, let me talk about something called the position vector. Right? So we have position vector R. So what is a position vector? It is simply a vector which is drawn from the origin to a particular coordinate, right? Which is, as the name suggests, telling us about the position of a particle in space, right? So this is a conscious choice that instead of telling you the coordinates of the particle, I will tell you the position vector of the particle. Essentially, these two things are exactly the same. However, uh, expressing the position as a position vector has certain advantages, right? As you will see. So if the particle moves from here, and let's say that the particle eventually reaches this point, I can call this the final position vector, right? Like we discussed last time. And then I can call this the initial position vector. And now I can define another vector which will be called the displacement vector D. So D is the displacement vector. What is the displacement vector? Well, the displacement vector is a vector which is drawn from the initial position of a particle to the final position of a particle, right? ये बहुत ही important है, because what happens is that you have been taught, most of you have been taught that displacement vector is a straight line, I don't know, smallest line or something like that, मेरे को याद नहीं क्या पढ़ाया गया आपको, but for us from now on the displacement vector is simply a vector which has been drawn from the initial position of the particle to the final position of the particle, right? The initial position and the final position are basically the positions of the particle at two arbitrary moments in time which you have designated initial and final, right? हाँ, तो subtraction इसमें हो रहा है ना, दिखाई दे रहा है ना. D is equal to RF minus RI. So to find the difference between two vectors, all you have to do is draw the two vectors from the same point. And once you have drawn the two vectors from the same point, you just draw a vector from the head of the negative vector, in this case that is Ri, to the head of the positive vector, which in this case is Rf. Okay. Okay, so the displacement vector is final position vector minus initial position vector. And like we discussed last time, I told you that this displacement vector D, this displacement vector D is equal to the velocity vector multiplied by the interval of time in which the particle is moving, right? ऑडियो नहीं अच्छा आ रहा है, वो उल्टा तो नहीं पकड़ा है। मैं कहीं उल्टा पकड़ा हुआ है। अब सही आ रहा है, थोड़ा बेटर है अभी। So since D is equal to RF minus RI, therefore we get RF minus RI is equal to V delta T, or RF is equal to RI plus V into delta T. This then would be the vector equivalent of the equation speed is equal to distance upon time, or distance is equal to speed into time, right? And we, I think we did a question last time where we applied this equation to find the position vector of a particle, right? Okay, so I'm going to give you two more equations, right? And remember that apart from this, the concept of the unit vector is used. That means that if you have two vectors having the same direction but different units, you can always divide them by the magnitudes and equate. Remember this? याद है? ये भी हमने use किया था last time. Okay, so let me give you two questions before we move ahead. So question number one is that we have a ship at position vector 3i cap minus 4j cap kilometers moving with velocity 3i cap plus 4j cap kilometers per hour. Okay. A motorboat at minus 2i cap minus 4j cap is, or can move with speed under root 50 kilometers per hour. Right? So I am telling you that after some time, collision occurs. Find time of collision and location. ये भी kilometers में है. So what I've given you is the initial position vector of the ship and the motorboat, velocity vector of the ship and speed of the motorboat, and I'm telling you that collision occurs. You have to find the time of collision and you have to find the location where the collision occurs. Okay, please attempt this quickly. Route 50. आंसर नहीं आ रहा है क्या मतलब भाई? आएगा आंसर। मैं तो सॉल्व करके दिखाऊंगा ही। पॉइंट ये थोड़ी ना है, पॉइंट ये है कि यू हैव टू ट्राई इट आउट ना। डायग्राम बनाता हूँ मैं। इतनी जल्दी गिव अप मार दोगे तो कैसे चलेगा भाई? हाँ, गंदा सा आंसर आएगा बिल्कुल। मोटर बोट यहाँ पे है और शिप यहाँ पे है। शिप की वेलोसिटी जो है वो ऐसे है। इसका मतलब समय के साथ शिप ऐसे चलती जाएगी। मोटर बोट को ऐसे चलना पड़ेगा और यहाँ पे हमारा कोलिजन होएगा। व्हाट डू वी मीन बाय, हाँ वियर्ड आंसर आएगा। हाँ, वैल्यूज आर्बिट्रेरी दी हुई है। व्हाट इज द मीनिंग ऑफ कोलिजन? कोलिजन का मतलब ही क्या है? कोलिजन का मतलब है कि क्या? Right, you have to understand the meaning of collision. What do you think collision in physics means? Yes, means same final position. हिट करेंगे एक दूसरे को, ये थोड़ी ना। सेम फाइनल पोजीशन मतलब है जाके लड़ाई झगड़ा करेंगे थोड़ी ना, मैं बोल रहा हूँ। हाँ, obviously. कैलकुलेटर से निकाला? चलो भाई देखो कैसे होएगा. Good. So the final position vector of the ship will be equal to the initial position vector of the ship plus velocity vector into delta t. I'm not going to write delta t, I'm just going to write t. So RFS is equal to 3i cap minus 4j cap plus 3i cap plus 4j cap t, which I can write as 3 plus 3t I cap plus minus 4 plus 4t. Right? I've just taken I cap, j cap together. Let's now work out the final position vector of the motorboat. This again will be equal to initial position vector of the motorboat plus the velocity vector of the motorboat multiplied by time. But velocity vector of motorboat is unknown. So what I'm going to do is I'm going to assume that the velocity vector of the motorboat is given by xi cap plus yj cap. Okay, I'm going to change the slide now. Please take a screenshot if you want. So the velocity vector of the motorboat is going to be placed here. Right? So I get final position vector of the motorboat is equal to the initial position vector, which is minus 2 minus 4j. Initial position vector minus 2i cap minus 4j cap plus the velocity vector of the motorboat into time. So it's minus 2 plus xt plus minus 4 plus yt. Right? Now, if the collision is to occur, if the collision occurs, then the final position vector of the ship must be equal to final position vector of the motorboat. Yeah? And if two vectors are equal, we write it here. So if we have something like xi cap plus yj cap is equal to ai cap plus bj cap, then this implies that x is equal to a, y is equal to b. ये ना ये necessary है. ये दोनों जो coefficients है वो equal होने चाहिए. So if RFS is equal to RFM, this would mean that this vector will be equal to the vector we have just seen. So I'm going to get 3 plus 3t is equal to minus 2 plus xt. Okay, and I'm going to get -4 plus 4t, यही है ना, -4 plus 4t है ना, -4 plus 4t, -4 plus 4t is equal to -4 plus yt. Okay, so this is very nice because in the second equation, this cancels out. And t, of course, will also cancel out. So I will get y is equal to 4. Okay, that is all I need actually, because if the magnitude of velocity of the motor boat is equal to √50 and my assumed value of velocity of motor boat is xi cap plus yj cap, then this implies that x square plus y square is equal to 50. So x square plus 16 is equal to 50, and x should be equal to under root of 54. Right? What have I found? I have found the x and y values of, I have found the velocity vector of the motor boat. Okay? And once this is done, the remaining thing must be very easy, because what I can do now is I can use this equation to write, I can use this equation to write 5 is equal to x minus 3t. So t must be equal to 5 upon x minus 3. So t must be equal to 5 upon root 34 minus 3, which is, कितना आएगा ये, around, can you use your calculators and tell me कितना आएगा roughly, कितना आएगा? Root 34 will be 5 point something minus 3, 2 point something, 5 divided by 2 point something. This is 1.78. Okay. And where does the collision occur? Where does the collision occur? To answer that, all you have to do is put in the value of t either in this equation, but यहाँ पे थोड़ा सा गंदा है क्योंकि x और y की values डालनी पड़ेगी. It does not matter. You can put in the value of t in this equation. Whatever is the final position vector of the ship must also be the final position vector of the motor boat. Yeah, सबको समझ में है. This is understood. Can you see the solution now? Any step which is not understood, please tell me. आ गया ना समझ में? ठीक है. चलो. So कितने दिन बाद मेरी आवाज सुनी भाई? कल ही तो मिस हो गया था मुझसे. quadratic क्यों? Why do you want? Why quadratic equation क्यों चाहिए? भाई अगर हमारी जिंदगी अच्छे से निकल रही है तो हमें अपनी जिंदगी में बाधाएं डालने की क्या जरूरत है? या हाँ, हो गया, बढ़ो आगे. Should I give you the next question now? Okay. चलो, again, be very careful with this question. So we have two particles move such that A starts from minus 20,0, moves with velocity 2 I cap meters per second. B starts from 10, starts from 0, 10 and moves with velocity minus 3 J cap meters. Find minimum distance between A and B and time when this happens. Yeah, so please remember, this is just an application of what we have learned till now. 10 रूट 5 कैसे निकाला ये बता दो मेरे को. आंसर मुझे थोड़े मालूम है, डालो पहले फिर बताता हूँ. क्या हुआ भाई, किसी का नहीं हो रहा है. Use the concept of vectors. And this, इसका क्या मतलब है, क्या यूज करना पड़ेगा, ये वर्ड आ गया ना यहाँ पे. I told you ना, whenever this word comes along, what do you have to do? आंसर मुझे याद नहीं है, अभी मैं वर्कआउट करता हूँ तो you can compare your answer, but what does this word mean? Yes, you have to differentiate, because if you visualize the motion of these two particles, then the distance between them is constantly changing, right? पहले कुछ डिस्टेंस था, बाद में कुछ और डिस्टेंस हो जाएगा. मिनिमम डिस्टेंस निकालने के लिए कंटिन्यूअसली चेंज हो रहा है ना डिस्टेंस. मिनिमम डिस्टेंस निकालने के लिए हमें डिफरेंशिएशन भी यूज करना पड़ेगा. So how are we going to use differentiation here? What are we going to differentiate? Well, the question में given है to find the minimum distance between A and B. So you have to differentiate the distance between A and B. How do you find the distance between A and B? Well, if you were to draw a position vector from A to B, that would give you the magnitude of that vector would give you the distance between A and B, right? So can you find the vector of A and the vector of B? मैंने तो अभी 1 डायमेंशन में दिया है ताकि इजी होए. 1 डायमेंशन में नहीं आएगा क्वेश्चन, 2 डायमेंशन में आएगा. I'll draw the diagram. So you have particle A, which is starting from -20 with a velocity of 2 I cap. This means that we have particle A which is starting from this point, and it is moving with a constant velocity of 2 I cap. Move करते जाता है यहाँ पर. इसके बाद से we have a particle at this point, particle B, and it is moving with a velocity of -3 J cap. ये ऐसे मूव करते जा रहा है. ये पार्टिकल B है, ये पार्टिकल A है. So can you tell me what is the final position vector of particle A and what is the final position vector of particle B? दोनों का final position vector क्या है? Must be equal to Ri plus Vt. Must be equal to -20 I cap, right? Plus 2Tj cap. And what is the position vector of this? 10J cap minus 3Tj cap. So RFA is -20 plus 2Ti cap. And RFB is equal to 10 minus 3T J cap. अब किसी मोमेंट इन टाइम पे अगर पार्टिकल P यहाँ है और पार्टिकल A यहाँ है, ऑब्वियसली ये है इनके बीच का डिस्टेंस है, और ये वेक्टर हो जाएगा RA, ये वेक्टर हो जाएगा RB. तो ये डिस्टेंस बिटवीन देम निकालने के लिए मुझे क्या करना है? डिस्टेंस बिटवीन A एंड B is equal to mod of, बेसिकली पाइथागोरस लगाना है. और पाइथागोरस को अगर मैं थोड़ा हाई फाई लैंग्वेज में कर दूं, क्योंकि कल तो मुझे ये 2 डायमेंशन में भी प्रॉब्लम तब नहीं होगी। रिजल्टेंट नहीं है, डिफरेंस। रिजल्टेंट, हाँ रिजल्टेंट भी बोल सकते हैं, नहीं पड़ता है। अब करो, नाउ डू इट। नाउ डू इट। ओके, ठीक है, यही किया ना जो मैंने लिखा है। तो ठीक है। मैं नेक्स्ट क्वेश्चन दे रहा हूँ फॉर दोज ऑफ यू डन दिस वन। ये वेक्टर्स का क्वेश्चन है। I wanted to give this question before, but I think I missed out. This is vector A and vector B. Find the component of A along and perpendicular to. This is question number 3. दो आंसर है ना इसके. No, planes are not. So if there are only two vectors, and the two vectors, they are part of a plane. Right? They are themselves specifying the plane. Theta is not given. ना theta तो है ही नहीं ना. थीटा के टर्म्स में आंसर आ ही नहीं सकता है. थीटा तो गिवन ही नहीं है. मेरे को जो आंसर चाहिए दैट शुड ओनली बी इन टर्म्स ऑफ वेक्टर ए एंड वेक्टर बी. Yes, of course you can. You can include dot product, you can include cross product, but remember that the component of A that I'm talking about must be a vector quantity. Yes, that's good. Yes, that's one answer. Yes, both sequences. नहीं. अच्छा, you are telling me that नहीं, गलत है. एक मिनट यस नहीं ये गलत है हाँ मैं करके दिखा रहा हूँ ये वाला हो गया क्वेश्चन पहले ये वाला कर लेते हैं तो बेसिकली यहाँ पे क्या करना है हमें नहीं ये गलत है because you are only telling me the magnitude you are not telling me the direction चलो so पहले we'll do this one -20 plus 2t 10 minus 3t ये आई कैप में आएगा ये जे कैप में आएगा so the distance between A and B is under root of -20 plus 2t whole square plus 10 minus 3t whole square